All right, ladies and gentlemen, so we're going to finish up chapter 10.2. This is our applications. So if you look, this we're working on goal number 4, solving applied problems involving parabolas. All right, so let's get started. I got 2 quick examples. You'll see that these are really easy. And here we go. Example number 1. We'll scroll up here. Example number 1, we have a satellite dish, and it's shaped like a paraboloid. Now, a paraboloid is basically a 3-dimensional parabola. So if you take a parabola and then spin it 360 degrees, it creates a 3-dimensional shape, which is a paraboloid. Okay? The signal that emanates from a satellite strikes the surface of the dish, and then it's reflected to a single point where the receiver is located. We call that the bounces off, reflects back to the focus, right? So the focus is in the dish. Okay, that's where the receiver is located. Dish is 8 feet across and it's at its opening and 3 feet deep at its center. At what position should the receiver be placed? Meaning, where are we going to put this focus? Okay, so that's the big idea is we want to find the focus. And we know there's a value that we need to find so that we can find the focus. What's the value that you need? Yeah. Yeah, the A value. So we need to find A. If we can find the A value, that's the golden ticket, guys. All right. Now, to help us, the best way to do this is just to graph this. Okay. So I'm going to make a basic X and Y coordinate grid here. And I'm going to graph a parabola. Now, you could decide, it's your choice, you can decide where to put the parabola. You can have it going up, down, left, or right. I'm pretty generic, so I'll put it just up and down, and I'll have the vertex at, what do you think I put the vertex at to make it easy? 0, 0. So I'm going to put the vertex right here at 0, 0. Okay? And I'm going to make a just basic parabola going up. I'm going to try to make this equal on both sides. And there we go. There's my parabola. Okay? So I always draw those with the vertex at 0, 0. Okay? All right. What other information did they give us? What information did they give us? Dane?
The distance from the vertex to the focus.
Yeah, that's what we're going to find. We got to find A, the distance from the vertex to the focus. What information did they give us in the word problem? What does it say?
8 feet.
Yeah, so the opening up here is 8 feet across. So going across, that's 8 feet from here to here. And what else did they give us here?
It's 3 feet deep.
Yeah, it's 3 feet deep. So from the top here down, that's 3 feet. So let me use another color so it pops a little bit here. So this guy's 3 from here to here. Okay. All right, so that's the information they gave us. Now let's talk about this equation that we have, right? It's a smiley face, right? This thing's going up. Bless you. So I'm going to use my x1 where it's squared. It's a smiley face, and we said positive people smile. And let's plug in what we know so far, right? We know h and k. This is our h. This is our k. So we plug that in. We get x minus 0, which is just x squared. You have 4a, and then y minus k, y minus 0, which is just, bless you, 4a, y. That's an a here. And that's who we got to find. So we got x squared equals 4ay is the formula we're using. Okay, any questions why we're using that formula? Well, we still got to find a, guys. Once we find a, we're good. Well, if I look, I'm left with an xy. So xy usually represents what? What's xy? That's a coordinate point. So if I can find a coordinate point on my graph, then I can solve this thing. Okay? Can anybody think of a coordinate point that we're going to have on this graph? Given the information, this thing's 8 feet across and 3 feet deep. Reese, what do you think?
0.3.
0.3. Well, we got to find, so questions thought was 0.3 would be here, but we have to find something on this parabola. So 0.3 is a good guess. Unfortunately, that's not it. Okay, Joshua? 8.3? 8.3, it's a good guess. 8.3 would be way over here somewhere. So it's not 8.3. Yeah, why 4? Yeah, so going across is 8, but if I look, this is 4 and this is 4, that makes 8, right? So the idea is this is over 4 and up 3 for a coordinate point 4, 3. Does that make sense? Perfect. So that's called brainstorming, guys. We came up with the idea of 0.3. That's close, but it's got to be on the parabola. We thought 8.3, but that's off the parabola. And then we kind of narrowed it down right in the middle to 4.3. Doesn't that make sense? That's great. So this is our x. This is our y. Now we just pluggy chuggy and we figure out what that value is. So x is what? 4. So 4 squared. And I have 4a and then times y. What's y? 3. We know 4 squared is 16. We know 4 times 3 is 12, so 12a. We just got to find what a is. Go ahead and divide by 12. You throw that in your calculator. What is 16 divided by 12? Yeah. 4/3. Which is what, 1/3? Okay, so if I'm gonna, this is a word problem, have some descriptors on what we're doing. So we want the focus about 1 1/3 foot or feet from the vertex or the base of the dish would be the vertex. Okay, so that focus should be about a 1.3 feet from that vertex. And that's the big idea, guys. Trying to find that a value. All right, so take a second. Why don't you set up number 2? Number 2 is very similar to number 1. Any questions on 1, y'all? So number 2, I got a satellite dish, again, shaped like a paraboloid or revolution. Signals emanate that satellite to strike the surface of the dish and are reflected to a single point, the receiver. Again, that's your focus. The dish is 10 feet across this time, and it's 4 feet deep at its center. At what position should that receiver, that focus, be? So take a second, see if you can't draw that out on your own. I always do the same parabola. I go up and down. There we go. Again, I have a vertex at 0, 0, so the formula we typically use for these are this guy here. Where h and k is 0, so we don't need to include those. How deep is this thing? 4 feet deep. So this guy's 4. And then how far across is this thing? So from here to here is how far? Dom, what do you got there? How far across is it?
Oh, it's 10.
10. So if we cut that in half, that's 5 and negative 5 here. So the coordinate point we can use is right here at 5, 4. Make sure you don't have 4, 5. That's a common mistake. People get those mixed up. Remember, it's over 5, up 4. And I would just pluggy chuggy, right? You plug that in. 5 is x. 4 for y. 5 squared we know is 25. 4 times 4 is 16 times a. And then we go ahead and divide. And what's 25 divided by 16? What is that?
1.56.
25 over 16 is about 1.56. You guys okay with that? So again, have some kind of descriptor. So that focus or receiver should be 1.56 feet from the base or from the center or from that vertex. Okay, easy peasy, lemon squeezy. Yes, sir.
Can you do either an improper fraction or a decimal?
Yeah, I would accept either, but in the real world, like if somebody said, "Hey, I want you to be 25/16 away," I'd be like, "What? What are you talking about?" So if you said, what is that? Or 9/16, I should say. That might be a little bit more accurate. If you're using a measuring, tape measure. Okay, so 1 and 9/16, I could do that. Okay, or about 1.56. So that's a good question. All right, any questions, y'all? So solving these applied ones, it's pretty easy once you put it. Basic idea, guys, graph your parabola. Have the vertex at 0, 0, which makes it super easy to graph them. And then from there, you should be able to answer the question pretty easily. Okay, you have 4 examples for the weekend, the long week, and that's it. All right, let me stop recording here.